Hello everyone, my name is Xiang Sunchen. I come from Shanghai Jiao Tong University. Today, I am going to talk about taking a close look at success by grading attributes analyzing for person ratification. Well, what is person ratification? Person rati is to find a person of interest from different kind of view. For basic ID system, there are always a lot of attributes which influence the final performance of reality system. These attributes can be viewpoints, weather, illumination, and so on. So here comes a question. How does these attributes influence the final performance to reality system? Which one is most important one? To find an answer to this question, first, we define a novel task, which is fine-grained attributes analyzing in-person reality. Unfortunately, traditional datasets cannot satisfy the need for this challenge task. That is because these datasets are always in small scale. To be more specific, their lack of diversity in viewpoints, weather, illumination, and poses. So these datasets cannot satisfy the need of the fine-grained attributes analyzing in-person reality. Importantly, previous methods always focus on achieving a satisfactory performance and sacrifice of training time and human labor expenses, while neglected to explore the potential of performing efficient training from millions of data. To address this challenge, we propose to upgrade and enrich all previous datasets GPR to a new one. This is GPR Plus. Compared with all previous dataset GPR, our new dataset GPR Plus has large number of identities and bounding books. And these datasets are always varies in terms of viewpoints, weather, and illumination. Based on our new upgraded dataset GPR Plus, we propose an end-to-end systematic framework which contains three stages. The first stage we call synthetic dataset generation, and the second stage is called dataset attributes analyzing, and the third stage is called reality evaluation. For the second stage, dataset attributes analyzing, first, inspired from the traditional transfer learning method, we construct a content representation and style representation respectively, and then we formulate a total representation based on content representation and style representation. And there are two hyperparameters alpha, beta, which control the relative importance of style representation and content representation. So as for the third stage, reality evaluation. First, we adopt an initializing model, ResNet 15, which is pre-trained on a large-scale dataset ImageNet. Then, already backbone is built with commonly used knot spectrum, such as triplet knots and identity knots. Note that the whole training process is performed without bells and whistle, so it can be very easy to implement it in PyTorch framework. So as for the loss distribution, as you can see the right figure, when performing ready task from GPR Plus to market, you will find there are two attributes which have no total loss value. They are sunny and clouds, which means these two attributes are much more closer to target domain. For example, market datasets. So we can perform graded search for NOAA North value in terms of viewpoints, weather, and illumination, and then we can find the optimal attribute in our ready task. As for the attribute importance, from this figure, it can be easily observed that identity always accounts for the largest score, which means identities is most important attribute in our ready system, following by weather, illumination, and viewpoint. So when performing ready tasks from GPR plus to Google datasets, we can also draw the same conclusion that identity is very important in this ready task. And the weather and the illumination is a little some kind of importance their viewpoints, that identity is always the most important one, following by weather, illumination, and viewpoints. As for results of fine-grained attributes analyzing, when performing ready tasks from GPR to market datasets, we can find that use more identities and training sample is always beneficial to a ready system. For example, as you can see from this table, first, when performing training with 100 identity and training set, you can find that all ready system can achieve 4.8% in terms of read MAP accuracy. However, if we increase our training set to 800 identities, so the performance can be improved to 17.4% in terms of MAP accuracy, which leads to 12.6% in terms of MAP accuracy when performing ready tasks from GPR plus to market datasets. Second, we can see that obtaining some optimal attributes can always lead to more satisfactory performance. For example, if we use all attributes and training sets, we can only achieve rank 1 accuracy of 41.8%. However, if you use some optimal attributes as training set, we can achieve 44.1% in terms of rank 1 accuracy, which can lead a significant improvement of 2.3% in terms of rank 1 accuracy. That's already amazing. So, and from when performing ready tasks from GPR plus to Duke datasets, we can also join the same conclusion and use more ID and training set samples is always beneficial to a ready system, and opting some optimal attributes and the training set can need much more satisfactory performance comparing use all attributes and training set. So this conclusion is very meaningful. So let's make a conclusion. First, we upgraded and enriched our previous dataset GPR to a new one, GPR Plus, which has a large number of identities and bounding boxes. Based on our new upgraded datasets, we introduced a new fine-grained analysis strategy to qualitatively assess the importance of different attributes, such as viewpoint, weather, and illumination. Third, we conduct a comprehensive experiment to explore the influence of various attributes on basic ready task. And the conclusion is very meaningful since they can provide guidance for us to construct a high-quality dataset to ready community. So in the future, we will continue to construct data from more virtual scenarios and cameras, as well as rich details related to identity level. And second, we will also explore the mutual benefits of multiple attributes for fine-grained attribute analyzing in ready task. So this work is still in progress. So that's all my presentation of my work, and thank you for listening.